Hey everybody, it's Mr. Oaks. Going to talk today about scatter plots. Now, scatter plots are a way that we can visually see the relationship between a set of data. It's just basically putting points on a graph, and that's it. We don't connect them. It's not connect the dots. We just put the points on the graph. So behind me, I have a table that has some information. It basically has hours spent studying and the test grade received. So we're saying that during a test, a teacher took a survey of the students, found out how long they studied, and then they took the test, got a grade, and the teacher wanted to see, is there a relationship between the number of hours that a student studies and the grade they get on a test. If you think about it, it does make sense that the more you study, the higher your grade's going to be. So there's certain things that we kind of feel like there should be what's called a correlation, that one influences the other. So one way we can do this is we can then use this information to make our scatter plot. So what we're going to do is I have my graph, and if you look, you'll notice my y-axis is the test grade, and I'm starting at 50 because if we look, the lowest grade over there is a 75. So we want to have a little bit of room beneath and then be able to go up to whatever the highest is, and maybe have a little bit higher than that. So we've got 50, 60, 70, 80, 90, 100, and we have a little dash here for, that would be 55, 65, and so on. Along the bottom is hours spent studying. Again, I'm giving a little bit of room. Each dash along here, along the x-axis, is a half hour. So this is half an hour, 1 hour, 1.5, and so on. So what we're going to do is we're going to look and we're going to just start doing our thing. So the first one we have up there is the student didn't study at all, and they got a 75. So I'm going to start here at 0, and I'm going to go up, and I'm going to put a point. I'm going to make them kind of big. Oh, I'm not even paying attention to what I'm doing. It's got to go up here. My bad. It happens. All right, so that's the first one. So at half an hour, one student had half an hour, they got an 80. Let's make sure we put this in the right spot. So that's right here. Okay. The next one, students studied for 1 hour, and they also got an 80. So I put a dot there. Next student also studied for 1 hour, but in this case, they got an 85. So I'm going to put a dot over at 85. 1.5 hours, a student got an 85. So again, I'm going to follow this up and put a dot at 1.5, 85. Another student, another 1.5-hour student, but this student got a 95. We're going to follow that all the way up. Here's 85, 90, 95. 2 hours, this student got a 90. So that's right here. Make sure I'm on the right spot. Right there. Students studied for 3 hours, they got 100. So we're going to follow that all the way up to 100. So put that right there. And another student studied for 4 hours, and they got a 90. Okay, so 4 hours, 90. Sure. So now, we're not going to connect these points. Okay, I'm actually going to move this so that the camera sees a little better. We're not going to connect these points. We're just going to see, does it look like there's a relationship between the amount of hours studied and the grade? And when I look at that, it definitely looks like if I wanted to, I could draw a line. I could draw a straight line to represent this. Now, if I was to draw a straight line, that would be called a trend line. And it's something that we basically could use to predict, well, what if the student studied for 2.5 hours? What would be the grade that we expect that? I would be able to draw a line to to represent this data, and then I would be able to make predictions based off of that line. And my prediction might be right, might be wrong. I mean, if you look, we had 2 students who studied for an hour and got 2 different grades. So, you know, but I could take my line, I could start maybe here, and I could draw a line like that. It's a little bit curved. But you see, most of these dots are pretty close. However, we do have this one dot here. It's kind of outside of what most of the stuff is. We call this an outlier. We call it an outlier because it lies outside of what we mostly would expect. Okay? If we took this spot away, we could get a nice, very nice relationship there. Okay? And we can make predictions such as, do you think if a student studied for 10 hours, would they get an even better grade? Well, no, because the highest grade you can get, if we're not counting any multiple choice, extra credit, is 100. That's the best you can do. So obviously you had a student study for 3 hours and they got 100. So, you know, maybe somewhere around 2.5, 3 hours is a good time to study for this test. All right. Now, one of the things we also could have is we could have a grouping of very close points. Now I'm just going to draw a couple here. All right. So we can have something like this. And what this is called is a cluster. It's where we see a lot of points kind of gathered around, and we have things such as a point cluster, which the points all gather around kind of like a single spot that would be in the center. And we have linear clustering, which would be they cluster very close together, but you can tell they're kind of around a line. Now, we don't really have any clusters here. We don't really have many points that would be that. But what we do notice is that as a student studies longer, they do better, obviously with the exception of this one. So there's a correlation. And since it's as the number of hours spent studying increases, the test grade increases, we call that a positive relationship, positive correlation. Because they're relatively close, we can kind of say this is a strong positive correlation. Now, if they were more spread out, if they were still making kind of a line, but they were kind of spread out a little bit, we would call that weak. Now, I have a couple of things on this side, on the next side, that I'll show you. I'm kind of going a little bit more into it. So, here, I notice that I have a couple of clusters. I have a cluster up here, and I kind of have a cluster down here as well, because they're grouped together. They're kind of tightly grouped together. I also have some outliers because they're outside of what most of the data is shown. So that's what a cluster is. It's a group. Think of like there's a peanut cluster. It's a bunch of peanuts held together with caramel, and it's close together. That's what we have here. It's a bunch of dots that are kind of related, but they're in one spot. All right, and the outliers are the ones that don't really fit the rest of the data. Okay, but even the outliers can usually be helpful. And then we have our associations. Here we have a positive association, as you see. From left to right, it's going up. It's got a positive slope. All right, if we remember back to when we did slope at the beginning of the year, as x goes up and y goes up, that's a positive association. That's a positive slope. Here, this is a negative association because as our x value increases, our y value is actually decreasing. So this is a negative association. You can think of something like the weight of a bowl of fruit and how much fruit you eat. All right, how much time goes by and the fruits you can eat. So like eating the fruit and the weight of the bowl keeps going down. All right, that's actually not a good one because both would be negative. That doesn't work. But something like the negative association would be something like the amount of time that over time, and the weight of something that's drying. So time is increasing, but the weight of something that's drying, since the water is leaving and evaporating, the weight of that thing would just go lower and lower. So that's a negative association. Finally, we have here, there's no association. As you see, the dots are all over the place. I can't draw a line to represent this. I can't draw a line up. I can't draw a line down. There's no association. There could also be things like if the points kind of make a circle. That's not no association. If the points just go directly straight across or directly up, that's no association. All right? So that's some of the things with scatter plots that we can do. And it just shows us, well, how much does this data that we got, is there a relationship? All right, so if I see a relationship, is it positive? Or is it going up? As one goes up, is the other one going up? That's a positive. Are they close together and it almost makes a line? That's strong. Are they kind of spread out, but you can still see they're increasing as the other's increasing? That's weak. Going down, that's negative. All over the place, no association. With the exception of my little flub with the example for negative correlation, I hope this helps. And as you see, even I make mistakes. I hope everybody's good. Please be safe, stay healthy. See you soon.